like, share, and subscribe to my YouTube channel. Thank you for your support. In the previous video, we have entered the Chapter 7 Differentiations Part 1, which consists of basic rules, gradients of the tangents and normals, increasing and decreasing functions, and finally, the stationary points. So in this video, we are going to enter the Chapter 7 Differentiations Part 2. What's the content of this video? Please pay attention and watch this video carefully. Thank you. Hello guys, welcome back to this YouTube channel. This is Jonathan Goldfish. So in the previous video, we are talking about the introduction about the differentiations as the first calculus chapter among the pure mathematics one. Well, let's continue the syllabus, okay, by starting from the last topic, which is the rate of change. Okay? So, in fact, the differentiation of dy dx can be related by the rate of change. Usually, this links to the chain rule. Okay? So, the rate of change is usually related to the time. So, that's why the definition shows here as the rate of change of the variable respect to time. Okay? Unless the rate of change of the variable is respect to the other variable. Okay? Well, you must look through the question specified, right? So, what is chain rule that we have discussed in the previous video, which is the dy dx, okay, is equal to the dy of d any variables times the same variable divided by x. You can divide it like this, or rewrite the chain rules by using rewrite the rate change of the y and x, okay, by using the idea of the chain rule. Okay, where x and y are both variables. Alright? And there are some variety changes. If the variable increases, the rate change of the variable is positive. If the variable decreases, its rate change is less than 0. Like the change in the x-coordinate. By showing the graph over here, let's say I want to determine the change, the rate change of the y when the x-coordinate is increasing from this interval to the optimum point. I mean to the peak. Okay, from 0 to x1, let's say. So what you can see over here, the gradient is decreasing. Okay, no, I mean that its gradient is positive over here from 0 to x1. Alright, which means that the rate change for the y is increasing at this point. Alright, I mean increase in the decrease rate. Otherwise, this is so-called increase in the increase rate. Yeah, the rate of the rate change increases at this point. What about here? This is the decreasing in an increasing rate. Alright? So it depends on, the varieties of the variable is dependent on its rate change. Okay? Or we can say that the variable varies the rate change of it. So you should get to know about whether the proportionality of between the two variables, okay, if you are the physics students, and you must get to well analyze the change of the variables or the varieties, all right, by using the concept of the rate of change or the chain rule. But in physics, we won't use it, okay, unless there is a formula determinant or derived. Okay? So yeah, actually we have now we have officially end the lecturer discussions for the chapter 7 differentiation. So now let's proceed to the exercises for chapter 7 before before for the summary of the video. I mean for the chapter 7 differentiation. Alright, time for the exercises for chapter 7. Okay, so this exercise consists of 41 questions, but due to the length of the question was too long, we will only discuss 16 questions out of 41 questions over here. Now, let's start our first question. Find f prime x for each of the following, okay, the 8 parts. So f prime x means you have to obtain the first derivative for the following functions. Okay, let's start from A. fx is equal to 2x to the power of 4. So remember that what is the first derivative for the polynomial function? Polynomial function, what is the general polynomial function? Ax to the power of the n. Why to the power of x of the n? Because n is the highest degree. So how to get the derivative over here? Which is the first derivative lah. Okay? A as the coefficient remains unchanged, and the n multiplied it, and then n as the power minus 1. So that is your general formula to get the first derivative. Okay? So fundamentally, apply the same idea inside for each of the functions. So f prime x for the A is 2 times 4 times x, 4 minus 1, okay, which is 3. So the final answer is 8x to the power of 3, or 8x cubed. Okay? I may square it up. So did the same thing for the rest of the parts. Okay? B. fx is equal to 3x to the power of 5. How to get its derivative? 3 times 5, 15. And then 5 minus 1, 4. Okay? C. fx is equal to x to the power of 6 over 2. How to get its derivative? 6 times 1 over 2, you get 3. And then times the x to the power of 5. Why? 6 minus 1. Okay? And what about for the D? Okay, D. D is 3 over x. No worries, okay? In the AS syllabus, the question won't ask you to find out the integration of the 1 over x. No. But differentiation, yes, because it's very easy for you. Right? Because the syllabus assists for you. So you can convert the 1 over x into 3x to the power of negative 1 by using the indices laws. So the derivative is 3 times negative 1, negative 3, and then minus 1 is minus 2. Okay? So don't do any mistakes. Or you can leave it as negative 3 over x squared. But there's an alternative trick for you to differentiate the reciprocal polynomial function. 3 remains at the constant, of course. And what is x? So since it is reciprocal, which means that its power is increases by 1, okay, since it is in the reciprocal. And don't forget to put negative, since the x is in the denominator, negative 3 divided by x squared. Okay? So when x is in the denominator, its derivative, for its first derivative, okay, the variable increases its degree by 1. And don't forget to put negative as the x is in the denominator. Okay, learn this trick. Right? Okay, now for the E. fx is equal to, what about, let's copy about it. E, f, f is the fx is equal to negative 2. G is fx is equal to 4x to the power of the square root of x. for x divided by square root of x, and for the h is the fx is equal to 2x sub x divided by 3x cubed. Okay, now for the e. What is the derivative about it? Learn the trick that I have told you just now. 5 over 3, 2. Okay, 2 is on the denominator, multiplied by negative 2. So you have negative 10 divided by 3 and then x cubed. Why? Because the x squared in the denominator increases by 1 for the first derivative. Okay, f. F is way too easy for you. Okay? Because since there is a constant, so just put 0. Okay? By following the rules of differentiation that we have discussed just now. Okay, G. G and H is quite hard for you because if you want to differentiate it quickly, you must use the product rule. But in your syllabus, product rule and quotient rule do not exist for the AS syllabus. Okay? Instead, we can combine the variables by using the indices rule. So there is a 4x, and what about the 1 over square root of x? It is actually 1 over x to the 1 over 2, or we can convert to times x to the power of negative 1 over 2. So this is basically 4x 1 over 2. Or you can take the conjugate on rationalize, which you will get 4 sub x. Okay, it's the same as this one. So now you differentiate it. You will get 4 times 1 over 2, 2. And then 1 over 2 minus 1, it's 2x. 1 over 2 minus 1 over 2. Okay? So therefore, the first derivative for g is 2 over square root of 1, square root of x. Or you can leave it as 2 over x to the 1 over 2. Or you can leave it as 2x to the power of negative 1 over 2. Okay? As long your first derivative is equivalent to the other form. Right? Finally, we have touched the last part of this question. H. Okay. So there are 3 different forms, okay, with the different degrees. But we can simplify it easier. So we have the 2x divided by 3. So for the x negative 3, it is to the power of, multiply the x to the power of negative 3 times the square root of x is what? X to the power of 1 over 2. Okay? So you see, the multiplication for the same base, its power is sum. Okay? Because the x has the power of 1, like this, which means that you have to combine it into x to the power of 1 minus 3 plus 1 over 2. So it's 2x to the power of negative 3 over 2 divided by 3. And now you may find its first derivative. So what is it? Okay, 2 over 3 times the negative 3 over 2. This one is quite complicated. Okay, it's okay. I can guide you one by. I can guide it one by one. All right. So what you can see over here, 2 over 3 times 3 over 2, which you can cancel out to get negative 1. So I put negative over here to save some space. All right. Because your answer cannot be omitted too much. And what about negative 3? Negative 3 over 2 minus 1, which is negative 5 over 2. Okay? Well, you can leave it, you can leave your other form, the answer as negative 1 over x to the power of 5 over 2, as long these or both answers are equivalent. Okay, to be accepted by the examiners. Alright? Oh, I forgot the dash for the final answer. So yeah, this is how you differentiate from the mild, from the basic level to the advanced level of the first derivative that are involving polynomial functions in your AS syllabus. Okay? So yeah, we have done this question. Now let's move on to the next question. Alright, let's proceed to the next question, which is the question 4. Okay, it's under the coursebook. The curve y equals to x squared minus 4x minus 5 and the line y equals to 1 minus 3x meet at the points A and B. So which means that between the curve and the line, okay, there are two intersection points. Okay, for A, find the coordinates of the points A and B. So this part means that you have to find the two coordinates of intersections. So how to make it? So you have to think about simultaneous equation, okay? Because of there are two variables which are common, which is x and y. Okay? So write it out. And you don't have to worry too much because as we see over here, the curve is quadratic, right? So that's why the workings over here are very easy and convenient. Alright, label the two equations as the first and second equation. Okay, get rid one of a variable. For my method, it's equation 1 equals to equation 2. Okay, if you want to do the substitutions, okay, you may do so. Simplify into the quadratic equation, which is equal to 0. This is -1 and then -6. So for this, take the factorizations. Okay, what is the product of 6? 3 times 2. Okay, only 3 and 2 can make it 1. So write a 3 and a 2 at each side. Okay, what sign for each 3 and 2 to make -1? Okay, so 3 belongs to negative and 2, whereas 2 is positive. Okay, because x times x is x squared. When you expand it back into this expression, -3x and plus 2x to get -1, and 2 times 3 is -6, correct. So by right, your x coordinates are -2 and 3. Until here, this is the first two answers you have obtained as the coordinates of the each point. Now we have to find the y coordinates. Okay, start from x equals to -2. But remember, when you want to continue your steps, okay, in case of you don't have enough space for the below part, okay, draw a vertical line over here, and then continue workings on your right hand side, on the right hand side of your old workings, okay, to save some spaces. So substitute x equals to -2 into the second equation because I want to save time. Okay, so the y coordinates when x equals to 2, -2 is 7. Okay, and do the same way for the x equals to 3. Which is -8. So the coordinates that we obtain are -2, 7 and 3, -8. Alright, it doesn't matter that you didn't write the what this coordinate belongs to for each. Okay, as long you have found the two coordinates, this is the marking criteria. Alright, so for me, I would say let's label the coordinate A for the lower x coordinate and B for the other one. Alright, or you can swap it because it doesn't matter of the permutations, okay, or the arrangement of the coordinates for each numerical coordinates that you obtain, right? So let's proceed to the part B. Find the gradient of the curve. Okay, please highlight gradient of the curve for each of the points A and B. So use your answer obtained from the first part over here. Okay, and what the gradient of curve means what? The gradient of tangent, because the gradient for the curve is not constant unless you obtain the fixed point. The fixed points are A and B for each. So what is the curve equation? The first equation, which is quadratic. Okay, and to get the gradient of the curve, you have to take the first derivative for the curve. So take dy dx or differentiate it. So what is the derivative for the quadratic equation above? 2x minus 4 constant becomes 0. Take the power down and then minus 1. And for the 4x, get rid away the x. Okay? Next, find the gradient of curve. Okay, this makes your job easier. So the dy dx or the gradient of the tangent at point A is 2 times negative 2 minus 4, which is negative 8. So which means that at point A, its gradient is negative 8. So this is your answer for the gradient at A. Okay, repeat the same way for the B. We just only take the x coordinate for each. So the gradient at B is 2 positive. Okay? Yeah, the second question is very simple. First, the question tests you about the basics from your previous chapters. Okay, chapter 3. And for B, this is the actual topic for this particular chapter. Okay. So yeah, we have ended this discussion and let's proceed to the next question. Alright, this is the next questions that we have to discuss right now. This is the question 7, but it's under the course book. Okay, find the gradient of the curve y equals to 6 over the bracket square of x minus 1 at the point where the curve crosses the y-axis. Okay, highlight about the point where the curve crosses the y-axis. What does it mean? It means that this curve is a reciprocal function. Okay, so as it crosses the y-axis, what does it mean? It means that this point, the x coordinate of this point is equal to 0 because the curve cuts the y-axis. Okay? So, I want to get the gradient of the curve. Gradient of the curve at the fixed point. Okay, the point refers to the point we mentioned over here. Write out the equation and differentiate it once. So the dy dx of this is the power negative 2, okay, multiplied by 6, which is negative 12. And then this is the we have to use the chain rule because we are considering about the inside function. So anyway, it doesn't matter because the derivative of the x minus 1 is 1. So no worries, which you will get x minus 1, but you have to minus 1 about the degree. Or it is an increasing degree for the differentiation of the reciprocal function, which is 3. Okay, so this is your derivative or the gradients of the gradient of the curve. Okay, so you say when x equals to 0, what is the gradient of the curve or gradient of tangent at the point stated over here? Okay, which is 12. Why? Because minus 1 cubed is minus 1. Minus cancel out to get 12. Easy, right? So yeah, let's move on to the question 8. Okay, I mean question 8, but this is the next question to be discussed right now, right? Okay, the curve y equals to a divided by bx minus 1 passes through the point 2, 1 and has the gradient of the negative 3, 5 at this point. This point refers to the point 2, 1 over here. Okay, hence find the value of a and value of b. So usually this involves the simultaneous equation. Okay, so extract the information above. What it tells you that the point has the x coordinate of 2 and the y coordinates of 1. But at this point, its gradient is negative 3 over 5. Okay? So you have to grasp the topic, grasp about this these concepts, because this will be useful in the differential equations. So first you say when x equals to 2, y equals to 1. Okay, substitute inside the equations, which you will get 2b minus 1 equals to a, which you will get a minus 2b is equal to negative 1. This is your first equation. And what's next? Okay, now we are considering about its derivative or the gradient of the tangent, gradient of curve. So take the differentiations once. dy dx, which you will get, what is this? This is negative 1, right? So put negative. And what about the derivative of the below functions? It's b. So a times b divided by bx minus 1 bracket square, because of increasing degree for the differentiation of denominator. And what's next? When dy dx equals to negative 3 over 5 and x equals to 2, do it like this. Okay, negative can be cancelled out at both sides. What will you get? You will get the 2b minus 1 bracket square. Okay, and you can written as ab is equal to 3 over 5 2b minus 1 bracket square as your second equation. So obviously you must solve it by using the quadratic method. You must get a quadratic equation and solve it for one of the variables. Okay, and instead you can treat this as your first equation. A equals to 2b minus 1, okay, to save more time. And you say substitute the first equation into the second equation, which you will get a quadratic equation by right. So it's b times 2b minus 1 bracket is equal to 3 over 5 2b minus 1 bracket square. Okay, now you expand. 5 as a denominator, okay, just multiply 5 at both sides. 10b square minus 5b. What about this? This is the 4b square minus 4b plus 1. Okay, multiply it so. Rearrange, expand, rearrange, and simplify. I mean grouping. So this you will get b square. It's 2b square minus 7b plus 3. Okay, not enough space. Okay, factorize it, which you will get 2b minus 1 and b minus 3. Okay. So you will get the b is 1 over 2 or b equals to 3. Okay? And next, substitute the values of the b sub 1 into substitute the each values of b obtained into the first equation. What you will get for a, when b equals to 3, which you will get 5, and for the b equals to half into the first equation, which you will get 0. Okay, at this point, we have to decide which is correct and which is invalid. So two b's, only single values of b must be correct, and the others is wrong. Because the question says value. Value is a singular, right? So what you can see over here, for this curve, a cannot be 0, obviously. Which that means we have to decline this. We have to reject the answer for b equals to half, because this will get the b equals to 1 over 2. Okay, this statement that leads a equals to 0. So you have to restate again. The actual answer for the a is 5 only. Okay, meanwhile the b is 3. So which means that, okay, when you are practice the mathematics, okay, not only that you must have a good observations, but with a good deduction, with the clear logical reasoning, right? So yeah, okay, this question teaches you how to use your logical reasonings to obtain the valid and correct answers, okay, to satisfy the equation of the curve implied over here. Well, yeah, we have ended the discussion for this question. Let's move on to the next question. All right, let's move on to the next question, which is the question 12. All right, so this is also under the course book questions. Okay, the normal to the curve, y equals to 2x squared plus kx minus 3 at the point, okay, 3, negative 6 is parallel to the line x plus 5y equals to 10. Okay, so the question doesn't show the normal to the curve, but the normal line, the normal straight line is parallel, highlight parallel to the line, okay, the line given. So it prompts you that you have to find the gradient, okay, and then just to compare. This is your basic concept that you should know. Okay, so this normal line, which is perpendicular, which is normal to the curve, okay, the given curve, and this question asks you to find the x for the part A. Find the value of k. Okay. So the first thing is, take a look at the line, the equation of line, convert it into the intersect form. Okay, the intersect form of the straight, or the standard form. Not the standard form, it's an intersection form anyways. Okay, you will get negative 1 over 5x plus 2. So what can you observe is the gradient of this line, we can label it as m1 is equal to negative 1 over 5. Okay, just interpret from the straight line simplified or exchanged. Okay, so the normal line, okay, the normal line is parallel to the line with, let's say, line 1. So this is the line 1. that we have obtained. Okay, so since the normal line is parallel to the line 1, okay, where the gradient of line 1 is -1/5, that means the gradient of the M1, the gradient of the line 1 is equal to the gradient of the normal. Okay, therefore the gradient of normal is 1/5. But for the curve, okay, in order to find the gradient of tangent, we have to convert from normal to the tangent by using this. Normal is perpendicular to the tangent. So it's the gradient of normal multiplied by the gradient of tangent is equal to -1. So the gradient of normal is 1/5, okay, to find the gradient of tangent. So the gradient of tangent is 5. Okay, until this point, you are able to get about 1 to 2 marks. Okay, what's next right now? Obtain the gradient of the curve. Okay, the gradient of tangent to the curve by differentiating the equation of the curve by taking the first derivative of it, which is the dy dx. So the dy dx of the quadratic function is a linear function, 4x plus k. Constant is gone, and for the kx, the x is gone. Okay, and for the x square lah, its degree decreases by 1, and when its degree is multiplied with the constant coefficient. Okay, so by using your concepts, equate the mt to the dy dx, which is the gradient of tangent is equal to the first derivative. So it's 5 is equal to 4x plus k. But the point given is 3, -6. Okay, we just only obtain its x coordinate of the point, which is the x equals to 3. So substitute inside and you are able to get the k value. So simplify it, okay, and calculate 5 minus 12. The answer goes to -7. Get it? Okay. Part B. Find the coordinates of the point. Okay, highlight the keyword coordinates of the point where the normal meets the curve again. So by assuming that the k you found is -7 permanently, find the coordinates of the point where the normal meets the curve again. Okay, which means that the coordinates you find cannot be 3, -6. Okay, because it implies that the 3, -6 is one of the intersection point between the normal and the curve. So you have to carry out the simultaneous equation. So what is the equation of curve over here? But the k you obtain is -7, which means that you have to rewrite the equation of curve into y equals to positive 2x squared minus 7x minus 3 as your first equation. And don't misunderstand that the normal equation is this line, because this question only tells that the normal is parallel to this line, which means that the gradient is the same, but you have to use this point to form its unique equation. Okay, so to do so, you have to use the gradient proportion to obtain the equation of the normal. So the gradient above you obtain is -1/5. So it's y minus 6, okay, x minus 3, because of the coordinates of the one of the intersection point is 3, -6. Okay, use this graded expression equate to negative 1 over 5, which is the y plus 6, negative 1 over 5, x minus 3, moves up, which you will get like this. But we have to obtain the equation of the straight line in the form of y equals to mx plus c, which you will get y equals negative 1 over 5x, 3 over 5 minus 6, which you will obtain negative 7 over 5 as your second equation. Okay? Now you have obtained the both equations between the curve and the normal. Now let's solve the simultaneous equation between the two variables which are in common. So equate equation 1 and equation 2. Let's get rid away the variable y first. So 2x squared minus 7x minus 3 is equal to negative 1 over 5 x minus 27 over 5. Okay, sort and rearrange into the quadratic equation, okay, which is equal to 0. 2x squared remains, and what about this negative 7? Which is negative 34 over 5x. Negative 3 plus 27 over 5, positive 12 over 5. So I don't want to make my quadratic expression to be complicated. So let's get rid the fractions by multiply by 5. Okay, which you will get 10x squared minus 34x plus 12. So solve the quadratic by using the factorization, which you will get the factorization result of 5x minus 2 and 2x minus 6. Okay? So obtain the x value over here, which you will get x equals to 2 over 5 and 3. However, the question above that, the coordinates of the point. So the point refers to the next point. Okay? This point isn't 3, negative 6. So what you can see over here, the x coordinates, one of the x coordinate is equal to 3, which means that x equals to 3 has to be rejected. We only take the x coordinate of 2 or 5. Next, the last step is substitute the x equals to 2 over 5 into the equation exist, which is the equation 2 to save your time. But if you want to obtain or verify the y coordinates when x coordinate is 3, it's negative 6, please do so. But this takes you a lot of time. Okay, my best suggestion is don't do that. Okay, because we have to conserve some time for the other questions. Which you will get the y coordinate, which you will get negative 137 divided by 25. So rewrite your answer as the x coordinate is 2 over 5 and the y coordinate is negative 137 divided by over 25. Okay? So I don't believe that this is the correct answer, but we can still verify and see. Yes, that's correct. What about for the straight line equation? It is also correct. Right, so I believe that this is the final answer we obtained, as I expected. Right? So yeah, let's move on to the next question. Okay, move on to the next question. So this is the question 15 from the course book questions. Okay, the equation of the curve. The equation of a curve is y is equal to x squared minus y minus 9 divided by x squared. Okay? Find dy dx and hence explain why the curve does not have a stationary point. Anyway, we just differentiate first. So for this expression, okay, this question is meant to arrange like this, right? So instead, we can simplify it to a clear expression. Okay, distribute the denominator for each term, which you will get 1 minus 9 over x squared. And now we are able to differentiate, which is dy dx is equal to 1 is the constant, get rid away, negative, okay, this has a negative, so negative, negative, positive, 9 times 2, 18, x cubed. Okay? Now, for the characteristic of the stationary point, what is it? Okay? The fact you should know is the stationary point means its gradient of tangent is horizontal. So for the horizontal line, okay, the gradient of tangent dy dx must equal to 0. Alright, so 18 over x cubed is equal to 0. It's not possible. Okay? So this is perfect for our explanations to answer the questions over here. So you should write the statement over here. Why it does not have stationary point? Because, okay, dy dx is equal to 18 over x cubed, where the x cannot be 0. Okay? So for the x equal to 0, the gradient function becomes undefined. Okay? You can say its gradient of tangent is undefined. And it is not possible for the gradient function to be equal to 0. Okay, this is the best explanations. Okay, that is enough for you to obtain the marks for explanations. Right? Impossible. So, in mathematics, you don't have to write a long essay, okay? Because you are dealing with explanation. Just a simple explanations. Okay? Your answer must be straight to the point. Hopefully you got this. Right? So now, let's proceed to the next question. Alright, let's move on to the next question, which is the question 17. The curve y equals to 2x cubed plus ax squared plus bx minus 30 has no stationary points. Show that a squared is less than 6b. So, what does no stationary point means? It means that there is no solution for this equation. Okay, what is the fact? dy dx equals to 0. So that it must be represented by equation in terms of x. So let's obtain the equation in terms of x. Okay, I believe that the gradient function is a quadratic because the degree of this curve is 3. Anyways, let's differentiate it by taking the first derivative, which is the dy dx. Okay, take the dy dx, which you will get 6x squared plus 2ax plus b. So this is your first derivative in the quadratic expression. Now, for the fact of stationary point, dy dx equals to 0. Okay, 6x squared plus 2ax plus b is equal to 0. So, this statement has no stationary points, means that this equation does not have real solutions. So, relating to does not have the equation, the quadratic equation does not have real solutions, we have to think about what? 5, 4, 3, to 1. Okay, the answer is discriminant. Okay? So this is the prerequisite chapters that you have learned from chapter 1. Okay? When it comes to the equation does not have the quadratic equation, which does not have the real solutions, use the fact of b squared minus 4ac is less than 0. So what is the b? The coefficient of x, 2a squared. Bracket square, okay? Be careful to avoid any careless mistakes. What is a? The coefficient of x squared, 6. C, the constant. Now expand, just to simplify these inequalities, which is the 4a squared minus 24b is less than 0. Okay, move the 24b to the other side, which you will get, which is leading like this. Divide 4 at both sides, which you will get a squared is less than 6b. Therefore, shown. Okay? Until here, you have successfully proved that the answer required above. Okay, let me move upwards. Alright, so this is how you deal with the questions, okay, by relating the both concepts of the differentiation and the quadratic inequalities by using the fact of the discriminant. Alright, so now let's move on to the next question. Yeah, we are moving on to the next question, question 19, which is also the last question before we enter the challenging segment. Okay, no worries, this question is still under the course book, right? So this question is about the rate change. Okay, a point is moving along the curve y equals to 2 over x plus 5x in such a way that the x coordinate is increasing at a constant rate of the 0.02. Highlight this statement. X coordinate is increasing until 0.02 units per second. Take a look at the rate. Is per second. So which means that the t is the time in seconds. So we have to realize that x coordinate, which has the gradient of dx dt, or the rate change of 0.02 positive, because it says that the x coordinate is increasing at the rate of this. Now find the rate at which the y coordinate is changing. Okay, the question asks you to find the rate change of the y coordinate, which is the dy dt. Okay, we haven't know the sign of the dy dt. Okay, what is the pattern of the y coordinate, the changes in y coordinate? Okay, but it gives you the x coordinate when x equals to 2. Also, state whether the y coordinate is increasing or decreasing by refer to the sign of the dy dt you obtain. So first thing first, differentiate the curve equation, which you will get negative 2 over x squared plus 5. And then when x equals to 2, what is your numerical dy dx? Negative 2 over 4 minus 5. Okay, it's negative 11 over 2. So when it comes to rate change, what should you use? Chain rule, correct? So write out, introduce about the chain rule. Chain rule states what? It states that the dy dx can be written as dy dt times the dt dx. Okay, where the dt as the denominator and numerators, okay, for each to be cancelled out like this. Like the a over b is equal to a over c times c over b. It comes from a over b times c over c. Like doing the conjugate, right? So use the fact of this, negative 11 over 2 is equal to the dx dt over here, but it is the place over here between two of these have swapped. So which means that the dt dx must be the reciprocal of the dx dt, which is 1 over 0.02, and don't forget the dy dt. So eventually the dy dt you obtain must be a negative. So until here we can confirm the dy dt is decreasing because of this sign, which you will get negative 0.11, or you can write into the fraction, which is negative 11 over 100. That is your answer for the rate change over the y at x equals to 2. And don't forget to state that the nature of the y coordinates. So we can say y coordinate is decreasing because of the sign over here. Okay, if can, you may elaborate until at x equals to 2. Okay, the sufficient elaboration helps you a lot to score the marks significantly. So why the y coordinates is decreasing at x equals to 2? Because of the sign of the dy dt is negative. Okay, so which means that the y coordinate is decreasing at a constant rate of negative 0.11 units per second. If good, it is you are encouraged to write the units per second. Okay, for the further clarifications of your answers. Right? So hopefully you've got this. Right? So yeah, time for the challenging segments. Okay, here we go. Welcome to the challenging segment among the exercises for chapter 7. So this is question 21, but it is still under the course book questions. Okay. So there is a sector. Okay, this recalls the chapter 4 circular measure. A piece of wire of the length 40 cm is bent to form the exact same shape, which is the sector of the circle shown on the diagram shown on the right, with the radius of r cm and the sector angle of theta radians as shown in the diagram. The total area enclosed by the shape is a cm squared, the area of this entire sector. Next, express the theta in terms of r. So, a piece of wire with the length of 40 cm. So this is your perimeter of the sector. Okay. So how to get the perimeter of the sector? Sum of the two radius. Let's say the P of the diagram is 40 is equal to 2r plus r theta. Why r theta? Because of r theta is the arc length. Arc length over here, not the length of the chord. Okay? So it wants you to express the theta in terms of r. Okay? Now let's make the theta as a subject. Okay? Divide r at both sides, which you will get 40 over r minus 2. And why we can divide by r directly? Because of the r cannot be 0. Okay, remember about this. R must be greater than 0. This is the fact. Right? Okay. B. Show that A equals to 20r minus r squared. Okay, usually until this application of differentiation, it wants you to express the A in terms of one variable only. That sole variable is r. So introduce the area of the sector okay, which is half r square theta, the well-known formula of the area of sector. Okay, from A, from the A you have derived or expressed. Okay, get rid the theta by substitute the theta as the 40 over r minus 2. Now you expand, which you will get 20r minus r squared. Therefore, shown. Okay, so it's very easy. Usually the part B only is only worth 1 mark. Okay. So if you are able to express from the information given from the perimeter and the areas into the area of the sector in terms of R, like this. Okay, like the tackling questions we have discussed in the last video. Okay, now for the C, find the value of R where there is a stationary value of A. It means that A is stationary where its gradient is equal to 0. The gradient of A and R. So take the equation that you have derived from B. Now you differentiate these equations. Okay. The gradient of A respect to R, dA dr, is 20 minus 2R. And what's next? Stationary means what? Its gradient is equal to 0. So dA dr equals to 0, which is 20 minus 20R equals to 0. So the R is 10. Okay? The value of R is equal to 10, where the A is stationary. Okay? D. Determine the magnitude of and the nature of the stationary value. Okay, tell me, magnitude of the nature of the stationary point means what? The value of the second derivative, which is the d2a dr squared, which means that it is the gradient of A. Or in other words, we can say take the second derivative, or find the derivative of the first derivative. Okay, differentiate it again, which you will get 20 only. Okay, so no matter how much is R, the dA dr is always positive with the magnitude of 20. Oh, sorry, my mistake. The magnitude means you have to find the A. Okay, because of magnitude of this stationary value, which means you are finding the areas. So we can only know that the area over here is minimum. Now let's find the A. R equals to 10. What is A? It's 100 cm squared. So which means that for the A equals to 100, it is minimum point because of its nature of stationary point. I mean its value of the d2a dr squared is positive. Okay? So we have done the first question of the challenging segment, which is the question 21 over here. Now let's move on to the next question. Okay, let's move on to the next questions. Before we proceed to the puzzle questions, it is under the challenge segment and course book questions. Okay, the diagram on the right shows a right circular cone of the base radius of R and the height hcm from a solid sphere cut from the solid sphere of the radius of 10. The volume of the cone is VCM, which means that the volume of this solid, this cone is V, Cn cube. Okay, for the part A, express R in terms of H. Alright. So the solid sphere has the radius of 10, which means that here is the center point of the solid sphere. Okay, this has the distance of 10, as well as this. Alright. But this line has the height of the 10, but there's a 10. Okay, and don't forget that for the constant radius, this distance between this point and this vertices is also 10, because of the radius is constant for the solid, for the sphere. Okay, where the cone is taken away from the solid sphere. So we can relate like this. At the same time, you can see there's a right angle. So we have to think about there's a right angle over there. Use this information to express R in terms of the H. Okay, this is the right angled triangle we obtained. This is the right angle. What about this distance? So this is the point. This is the center point of the sphere, solid sphere. And what about this? How to get this distance? This is H, this is 10. So H minus 10. Okay? And this distance is 10, since this hypotenuse is the radius of the sphere, solid sphere. And this is R, don't forget. So by using the Pythagoras theorem, okay, relate by using the Pythagoras theorem, write out the R square plus H plus 10 bracket square is equal to 10 square. Now, expand and simplify and express the R in terms of H. So this is R square. Expand the bracket over here, which is the H square minus 20H plus 100. Meanwhile, for the 10 square is 100. So 100 can be cancelled out. Okay. Move the H terms to the other side. Take the square root of both sides, which you will get 20H minus H squared as the final answer for the expression of the R in terms of H. Okay, B. Show that the V is equal to 1/3 of the pi H square bracket 20 minus H. Okay, so what is the volume for a cone? It is the 1/3 pi R square. Pi R square is the area of the base times height. Why 1/3? Because it is the cone. Okay, right? So now this question wants you to prove that, okay, to get rid away the R, the term R. So what is the R over here? It is the square root of 20H minus H square to be squared. Cancel it out. What will you get? Which you will get 20H minus H squared. Okay, you can factorize the H outside to be multiplied with the H outside. Another H, which you will get H squared. Alright. Eventually, the V is equal to 1/3 pi H squared 20 minus H. So therefore, shown. Okay? So until this point, you have successfully proved that you have successfully proved the equation of the volume required. Okay? C. Find the value for H for which there is a stationary value of H. Okay? As the same for the previous questions, okay? Differentiate the equation of the V in terms of the H. Okay? Expand it back to be differentiated easily. Then you differentiate it. Which is the dV dH is equal to 1/3 pi, okay, 20 times 2, which is the 40 minus 1, and then 3H squared. Okay, and what's next? Equate the dvdh to 0, which you will get 1/3 of 40h minus 3h squared is equal to 0. Then you factorize the h again. (40 minus 3h). Okay, h is equal to 0. That is impossible, so rejected. The others is 40 over 3. This is possible for the h value. So the answer for the h value is 40 over 3 cm by right. Okay, D. Determine the magnitude and the nature of stationary point. So the magnitude means what? The value of V. Okay, so substitute the h equals to 40 over 3 into the equation, which you will get 1/3 pi, okay, multiplied by the 40 over 3 square, 20 minus 40 over 3. Okay, so to be safe, leave it in decimal. Which you will get either 320 divided by 881 or 3.95 in 3 significant figures. Okay, that is a magnitude for V, where the V is stationary. Alright? And the nature of stationary point, which means that you have to differentiate this again. Then you substitute the h equals to 40 over 3 inside the equation of the second derivative. So d2v dh square 1/3 40h 40 only minus 6h. Okay, when the h equals to 40 over 3, d2v dh square is equal to 1/3 of 40 times 6 times 40 over 3. Okay, use your calculator to calculate it. Which you will get, it's a negative, so it's negative 41.9. So since it is less than 0, means what? The stationary value of the 3.95, it is the maximum. The value is maximum. So yeah, that's all for it. Okay? So this is how you apply the basic concepts of the differentiations inside the geometry or the other mathematical application questions. Okay? So yeah, it is our time to discuss the past year questions. Alright, let's move on to the next question, which is the question 26. Okay, as this is the first past year questions are we going to discuss today. So this is the past year questions from 9709, October, November 2003, question 9 from paper 1. Okay, so refer to the diagram. Okay, there's a curve and 2 lines. Alright, the waterfall line is definitely the tangent line, which intersects with the curve at B. Okay, where the tangent crosses the x-axis at C. So let's highlight the few keywords here. Okay, why it still shows the A? Because this question might mix with the integrations. Okay, you may just ignore it, because we haven't involved integration yet. So highlight the equation of the curve as well as this statement. Point D is very essential because this coordinate will be used for the calculation of the area of triangle. Okay, so for the first part, the question wants you to find the equation of the tangent to the curve at B. Okay, equation of this line. Alright, and hence show that the area of the triangle BCD, which means this triangle, its area is 4 over 3. Okay? So first, let's perform the workings for the first part over here. Okay? Grab the equation of the curve. Then you take the derivatives, which is the dy dx, or differentiate it, which you will get negative 24 over 3x plus 2 bracket squared. Why? Because of the function is in the denominator. Okay, its power is negative 1, so you must put negative in front. Why it is 24? Because 8 times 3. Because 3 is a derivative of the inside function here. Okay? So I want to find the gradient of this line, which is gradient of BC or the gradient of tangent. Okay? So you say B at B to 1. What is your dy dx? Your dy dx is negative 3 over 8. That means your gradient of the gradient of tangent or the gradient of BC, you see there's a negative slope. So yeah, the gradient must be negative. And now for the equation of the tangents to the curve at B, or the equation of this straight line with the negative slope. So you should say at 2, 1, okay? So using the proportionality of the gradient, okay, y minus 1 divided by x minus 2, alright, the position must correspond to the, the position of the coordinates must correspond to each other, right? So either you can live in the standard form, or you can live your equation of the tangent in the form of the intercept form. So for me, I'll simplify into the intercept form. Okay. So this is the equation of the tangents. Okay, that's the answer for your equation of tangent. Now let's take a look at the next part of question. Okay, the question wants you to prove that the area of triangle BCD is 4 over 3. How to prove? Okay, ask yourself, what is the area of triangle? The half of the base times height, right? So the area for the triangle, right angled triangle, only it's half of the base times height. So the base is over here is distance CD, okay? Whereas the height is the height, the distance BD. So we don't have to use the distance formula to calculate the distance for BD because it's obviously 1. Alright, so let me draw a triangle for you. Just that we haven't known the coordinates of the C. So how to get the coordinates of C? You just say, because C is the x-intercept for the line B, for the tangent line, right? So you must say, you must get its x coordinates when y equals to 0. So what is the x coordinate for the C? It's 14 over 3. Okay? Right. So until here, you know that the coordinate of C is 14/30. Now time for the calculation for the areas. Okay. So first, I need to get the distance CD first by taking the distance formula. So we don't have to calculate. We don't have to use the distance formula with the complicated square root. We just deduct the 14/3 with the 2. Okay, it basically wants the horizontal distance over here, which is the distance CD. It's 8/3. Okay, CD equals to 8/3, and the BD is equal to 1. Now for the area. Okay, so the area of the triangle BCD is equal to the half times 8/3 times 1. Okay, and then cancel out the 2 and the 8. So in the end, you will get 4/3 as the area of BCD. So therefore, shown. Okay. Yeah, this is the question from the old syllabus. However, this is for you to must recall some fundamentals from what you learned in your secondary school. Okay, so this is as your applications, right? So yeah, we have ended the discussion for these questions. Let's move on to the next question. Okay, so this is question 30. It's a passive questions from 9709, October, November 2004, question 7 and paper 1, from paper 1. A curve is such that the dy dx is equal to 6 over the square root of 4x minus 3, and there's a coordinate of p, 3, 3 is a point on the curve. Okay, which means that this point in the is the one of the intersection point that lies inside the curve. But it only gives you the gradient function of the curve, right? So now, okay, since it only wants the equation of the normal to the curve, okay, in the form of the standard form, therefore you don't have to convert back into the equation of curve because that involves the integration. Start from dy dx. Okay, and what is the one of the point? Okay, P. It wants the normal of curve at the point P, which means if you plug inside the 3, if you plug the x equals to 3 inside this gradient equation, you will get the gradient of tangent at P. So you say P33 dy dx is equal to the 6 over 4, the square root of 4 times 3 minus 3, which you will get 2. Which means, okay, that means that the gradient of tangent is 2. But what I want is the equation of normal. Of course, it's a straight line, okay? So by relating the tangent and the normal, they are perpendicular to each other. Perpendicular, sorry. Okay, so by using the formula, mt, the gradient of tangent times the normal gradient is equal to -1, or the 2n is equal to -1. So the gradient of normal is half, -half. Okay, but it wants the equation of the normal at point P. Okay, so plug inside the P33 inside the proportionality of the gradient, which is the y minus 3 divided by x minus 3 is equal to -half. Okay, since the question wants the answer in the form of this general form, so you have to obey, you have to comply, which you will get 2y minus 6 because of you cross multiplied. Okay, and for this side you will get -x plus 3. So move the x to the left hand side, -6 to the right hand side. in the end you will get x plus 2y is equal to 9. Only this answer is acceptable. Okay, if you put inside the, if you leave as a intercept form, no marks for the answer because you didn't comply what the question demands, right? So yeah, this is one of the part I believe most of the calculus, most of the question, the calculus question involves differentiation and integration at once. Okay, let's move on to the next question. Okay, let's move on to the next question, which is the question 31. This is the past year questions from 9709, May June 2010, question 7 from paper 11. Okay, so following this diagram, okay, there is a curve of the with the equation of y equals to 2 minus 18 divided by over 2x plus 3, which crosses the x-axis at point A. Okay, and the normal to the curve at A crosses the y-axis at the C. So which means that this line is the normal line to the curve at point A. For the first part, show that the equation of the line AC is 9x plus 4y is equal to 27. So which means that you have to prove it out. The equation normal is the answer stated in the questions. Okay, take the equation of the curve and differentiate it. dy dx, what will we get? Constant disappeared. Negative, you get positive. 18 times 2, it's 36, sorry. Yeah, 36. Divided by the bracket square of the 2x plus 3. This is the gradient of tangent. But you don't have to find the y coordinates for the x. Wait a minute. Oh, sorry, I forgot about. We have to find the x coordinate for the A. So which means that we have to let y equals to 0 in order to find the x coordinate for the A. Okay? So you say when y equals to 0, what will be your x coordinate for the A of the A? It's 3. Okay? So when when x equals to 3 at A lah, the dy dx is 4/9. Okay, so which means that the gradient of tangent is the positive, because actually the gradient of tangent looks like this. So which means that, as you can see, the equation normal in the diagram shown must be negative. Okay, common sense. So this you can label as the gradient of the tangent. Now for the normal lah. Okay, normal is equal to the AC. So AC is perpendicular to the tangent. Therefore, the gradient of AC times the gradient of the tangent is equal to -1. Okay, tangent is 4/9. So the gradient of AC is -9/4. Because of A 30 is one of the intersection point of the equation AC. So you can write A 30 y minus 0 divided by x minus 3 is equal to -9/4. Cross multiply and simplify. Then you should get the answer stated from the questions. Exactly the same. Okay? So in the end, you will get 9x plus 4y is equal to 27. Correct. So therefore shown. Alright. Okay, now B. Find the length of the BC. Okay. So how to get the length of the BC or the distance of the BC? This distance. Okay. So it's just basically the intersection points without involving the differentiations. Okay. So label here as the second part. You can write when the x equals to 0. What is the y coordinates of it? So let's start from the curve. It's -4. Okay, so which means that the coordinates of B is 0, -4. And now for the normal line, the y coordinate is positive 27/4. Okay. Which means that the coordinates of the C is 0, 27/4. Okay. So until here, the length of the BC is 27/4 plus 4. Why plus 4? Because this is the -4, which means that it has a 4 units distance from the origin. For the C, it has the distance of 27/4 from the origin. Okay? Therefore, we can't consider about the negative distance of coordinate. That's why it's 27/4 plus 4. Okay? So in the end, you will get 43/4 as the length of the BC, or you can state in the decimal place, which is the 10.75. Okay? Yeah. So this is how you deal with the simple coordinate geometry questions. Okay? As well as it is linking to the differentiations. Okay. Good. Let's move on to the next question. Alright, let's move on to the next question, which is the question 33. So this is the past questions from 9709, October, November 2002, question 8 from paper 1. Okay, a curve has an equation of the y is equal to x cubed plus 3x squared minus 9x plus k, where k is the constant. For the first part, write down the expression for the dy dx. Okay, dy dx is the differentiation, is the first derivative from the curve equation. So take the first derivative, so we'll do 3x squared plus 3 times 2, 6x plus, it's -9. Answer. Okay? So usually this question only costs 1 mark. Alright? 1 mark for the correct final result of the differentiations. Second part, find the x coordinates of 2 stationary points. Okay? Highlight x coordinates. Okay? It's a plural 2, which means that 2 x coordinates, 2 answers of what? Stationary points. okay, on the curve. So what does stationary points this statement mean? It means that, okay, these two x coordinates gives the result of the gradient function as 0. Or in the other words, dy dx is equal to 0. Okay, this is the statement you should know. Because of the gradient of tangent is a horizontal line. So you can say dy dx is equal to 0, or equate your answer for the first part to 0. It's 3x squared plus 6x minus 9. So yeah, as you can see over here, the gradient function is a quadratic, which means that there's a power of 2, which means that fundamentally it has two solutions. Okay? Okay, so the x coordinates, one of it is 1 and the negative 3. Okay? That's the final answer. Two final answers. Okay. Third part. Hence is what? Use the result from the previous part. Find the two values of k, okay? For each respective x coordinates, for which the curve has a stationary point on the x-axis. So which means that you have to use the x coordinate you have found from the equation of the equation of the dy dx is equal to 0 to find the k. Okay. But it says here on the x-axis. Okay? So at this point, you may assume it's their y coordinates are both 0. Okay? So for the third part lah, when x equals to 1, y equals to 0. Okay? Use back the original curve equation, which is the y equals to x cubed plus 3x squared minus 9x plus k over here. So this is more likely to say you get the indefinite integral and this is your constant must be added. Yeah. So do it like this. So the first k value obtained is five. Okay, let's find out the second one. When x equals to negative 3, you will get k equals to negative 27 as the final answer. So yeah, okay, you have to do some assumptions in order to complete this part, alright? And it also shows a keyword of hence, which means that you have to use the result from the above two. Okay? So yeah, we have ended the discussion for this question. Let's move on to the next question. Alright, let's move on to the next question, which is the question 36. Okay? So this is the past questions from 9709, May, June 2007, question 10 from paper 1. Okay, the equation of the curve y equals to 2x plus 8 over x squared. Okay? For the first part, obtain expressions for dy dx and d2y dx squared. So what is dy dx? It's the first derivative, or you differentiate it once. This is the first order of the derivative. Okay? So from the equation above, I have highlighted over here. What is the first derivative? 2x, you get 2. What about 8 over x squared? Negative 8 times 2, 16, divided by x cubed. That is your dy dx, or the first derivative. Okay? So what about for the d2y dx squared? That it means you have to differentiate the equation twice, which means that you have to take derivative for one more time for the first derivative that you have done. So for the constant, get it away, and it's so this the power has the negative 3, so it's negative 16 times negative 3, or 16 times 3. So it's 48 divided by x power 4. That is your second derivative, okay, from the equation of the curve. Part 2. Find the coordinates of stationary points on the curve, okay, and determine the nature of the stationary point. So, coordinates means what? You have to find the both x and y coordinates. Okay, so what is the fact of the stationary point? Dy dx squared is equal to 0, or the gradient of tangent is equal to 0, or the tangent is horizontal. Okay, now set your first derivative is equal to 0. You will get these equations. Okay, now solve for the x, which you will get 2. So 2 is the x coordinates of the stationary point. Now, when x equals to 2, you must substitute back to the original equation. Which you will get 6. So the answer for the coordinates of the stationary point is 2, 6. So it's not necessary that you have to rewrite the coordinates into the coordinate form. However, you must manage to get the correct coordinates, okay, for each. So this is the answer. But for my best suggestions, okay, please write into the real coordinate form will do. Alright? So for the third part, oh, I forgot. Sorry about I forgot to discuss this part for you. Okay, what about for the nature of stationary point? Given is 2, 6, which means that you have to substitute the x coordinate inside the second derivative that you have done. So for the coordinates of 2, 6, d2y dx squared is equal to 48 divided by 2 power 4. 2 power 4 is 16. You will get 3. Okay, the d2y dx squared is a 3, and it's positive, greater than 0. So what is your final verdict? It is minimum. But if you want to write in the complex sentence, okay, go on. But this will waste your time. As long you you must let examiner see there is a word minimum with the proof. What is the proof? The values, it is dependent on the values of the d2y dx squared, or the sign, its sign. Okay? And also, for the stationary point, you must manage to get the each coordinates. Right? So this is the answer. Okay, for the third part, show that the normal to the curve at point negative 2 intersects the x-axis at the point negative 10, 0. So which means that let the y is equal to 0, and you must manage to get the x-coordinate is negative 10. Okay, so this is the way. Normal to the curve at point 2, 2. So you must get the gradient of tangent at the point negative 2 and negative 2. So negative 2 is dy dx is equal to 2 minus 16 over negative 2 to the power of 3. So what is it? It's 4. So that will be your gradient of tangent. Now, tangent is perpendicular to the normal. So gradient of tangent times gradient of normal is equal to negative 1. 4 times mn is equal to negative 1. Okay, so therefore, your gradient of normal is negative 1 over 4. For the negative 2, negative 2, it is y plus 2 divided by x plus 2. Why? Because of y minus 2. And for the x as well. Okay. Then now you manage. Then now until this line, you are managing to get the equation of the normal. Which you get y equals to negative 1 over 4 x plus 3 over 2. Okay. So until here, it is time for us to show that the x coordinate is equal to 10 right here. Okay. So you have two methods to solve for the proof. Given the coordinate is 10, 0. Okay, the first method is let the y is equal to 0 to solve for the x. Oh, sorry, I did a careless mistake. Because this is plus 2, for this plus 2, you must move to the other side to get negative. So this is negative 5 over 2. My apologies. Okay. Because just now I spot that there's a mistake, okay? Alright, so make sure to double check your workings, okay, to avoid careless mistake. So by right, the x coordinate is 10, therefore shown. Okay, until here, we have shown that negative 10, 0, okay, is the x-intercept, is the point of the intersections with the x-axis, or the x-coordinate is equal to 10 when the normal line crosses the x-axis. This is the first approach. Okay, but you can use the second method, which is the alternative method. So you can say left hand side is y equal to 0. Right hand side is what? It's negative 1 over 4 times negative 10 minus 5 over 2. Okay, 10 over 4 is the 5 over 2 minus 5 over 2, which you will get 0, which is equal to left hand side shown. Okay, so until this point, you can say that negative 10, 0 is the point of intersection in the x-axis for the normal line, which is for the line which is normal to the curve at the point negative 2, negative 2. Okay, so this question seems very tricky, but if you perform your workings without any unnecessary careless mistake, all right, obtaining the full marks is no longer a dream. Okay, so yeah, let's move on to the last questions of our discussion today. Okay, finally, we are entering the last questions of our discussion among the exercises for chapter 7 for today. Before the summary of chapter 7. Okay, this is question 40. Okay, and it's also the passing questions from 9709, October, November 2010, question 3 from paper 1-2. So this question is about the rate change. Length x meters of a green anaconda snake, which is the t in years, is given approximately by the formula of this one. Okay, with the given intervals of the time from 1 to 10. Okay, using this formula, find the dx dt. Okay, dx dt is what? It is the first derivative from the equation. So now let's get the first derivative. 0.7 is the constant. Just put it outside. And for the trick to differentiate the square root function, first place the 2 square root of 2t minus 1. Okay, by considering about the chain rule, differentiate inside function, which you will get 2. And then you cancel out. Eventually, you will get 0.7 over square root of 2t minus 1. Okay, this only costs you 1 mark. Or you can treat it like this. X is equal to 0.7. You can convert it into index form, which is the 2t minus 1 bracket to the power of the 1 over 2. Okay, differentiate it so, which is the 0.7 times 1 over 2. Okay, 2t minus 1, 1 over 2 minus 1, negative 1 over 2. And don't forget the inside functions, which is 2. 2 and 2 cancel out. In the end, you will get 0.7 times 2t minus 1 brackets to the power of the negative 1 over 2, or the 0.7 over the bracket 2t minus 1 to the power of 1 over 2. So you see, in the end, it's equivalent. Both answers are equivalent to each other, right? So any kinds of answer which is equivalent, it's acceptable. Okay, next. The rate of growth, which is 5 years old. Okay? So you see, 5 years old means what? T equals to 5. Okay? And what it wants is the rate of the growth. The rate of growth means what? The rate of growth, I mean the growth of the green anaconda snake, which is represented by x meters. Okay? So what it wants is the dx dt. Okay? So yeah, just substitute the t equals to 5 inside the equation only. That's enough. Right? So just press your calculators. You will get 7 over 30. In decimal, it's 0.233 in 3 significant figures. That's all for this question. Okay? Alright, so we have finished the discussion of these questions. And also, we have ended the discussion for the chapter 7 differentiation. Let's go. Okay, here's the declaration. I declare that chapter 7 differentiation has officially ended. Now, let's move on to the summary for chapter 7. Okay, time for the summary for the chapter 7 differentiations. Okay, so in your AS syllabus, what you have to know about the differentiation is the rate change of the function respect to its domain. Okay, but the primary definition, it is the gradient of the tangent functions by using the limits as the approximations. Okay, I mean the limits to get its exact gradient of the tangent. Okay, so this is just for your understandings. Next is you should know 5 of these rules for the differentiations in your AS syllabus. Okay, because of only I tick with the magenta color. Okay, these formulas are only exist in the NF19. Okay, along with you during the external examinations. Okay, about the orders of derivative, at most you will learn until the second derivative. Okay. What about the gradient of tangent and the normal for any curve? You should bring your knowledge from your chapter 3 from the paper 1. Okay, inside this, you must apply it inside. Nt times Mn to get -1 because they are perpendicular. Okay, and some simple procedures to obtain the tangent and normals. Okay, you should get to familiarize by practicing. Okay, and for the increasing and decreasing function, okay, this subtopic is very common and it comes out in your exam if infrequent. Okay, so when it is increasing, when it is decreasing, by looking at the values of the dy dx. Okay, for the given interval. And what about for the stationary point? If you see the stationary point, you have to consider about the dy dx is equal to 0. This is the fact. Okay, and the d2y dx squared is to determine the nature of the stationary point that you've obtained. Okay, or it is the gradient of the gradient function. Okay, to see the nature of stationary point, whether it is increasing or decreasing, unless it is the point of inflections. Okay, and there's some procedures of finding stationary points that you should know. Okay, this is the best tackling ways to deal with it, as well as the applications in problem solvings. Okay, and lastly, for the rate of change, okay, chain rule is mostly involved. Okay, by listing out of the extra variables to be determined by the question demand. Okay, so yeah, we have now officially end the summary for the chapter 7s as well as this entire videos. Okay, so yeah, next chapter we are going to enter the last chapter among the pure mathematics one, which is the chapter 8 integration. So stay tuned in my next videos. All right, so thank you for your support. Please click on the subscribe button with the bell as well as the like, and don't forget to share. Okay, I will see you in the next video. Bye bye. Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.